All right, welcome back. Next up, chapter 8 is the square root property. We've actually already used this when we solved Pythagorean theorem triangle problems. So this will just be a quick little review. If we have a real number and x squared is equal to that real number, we can of course undo the square by taking the square root of both sides. So the square root of x squared will leave us with x. And then we have two solutions, right? In a triangle with actual side lengths. We of course only used our positive root. But if we don't have that restriction, we have two options. We have the positive root or the negative root, because either one of them will be solutions, because if I square them, I'll get k. So you undo a square with a square root. So if we know that u squared is 16, well, take the square root of both sides, use the square root of 16 or the negative one, right? So u is 4 or negative 4, because when you square 4, you get 16, and when you squared negative 4, you get 16. If we know that x squared is 28, well, we take the square root of both sides. So another way to write these two options at the same time is to say that x is plus or minus the square root of 28, right? So plus or minus, that means we actually have two numbers here. We're just condensing the notation. And of course, 28, it's got some perfect squares in there, right? That's 4 times 7. So that's plus or minus the square root of 4, which is 2, times the square root of 7. So that means our two solutions for x are 2 square root of 7 or negative 2 square root of 7. I think Alex makes you separate them with either the word or maybe a comma between. So even if you use this notation as you're working them out, make sure you know what it means and you can separate them at the end. Let's see, what if we know that 2x squared minus 128 is 0? Well, it's an equation. We're trying to solve for x. So as always, we need to start by isolating him. The outermost thing going on is this minus 128. So let's add the 128 to both sides. Now what's the outermost thing happening to him? Multiplying by that 2. So just like always, when we're solving equations, we start on the outside and work our way in. So the next thing to do is divide by 2. 128 divided by 2, that'll be 64, right? Now the outermost thing is that square. So we undo the square by taking the square root, and we have both the positive and negative roots, which of course of 64 is just 8. So our two options for x, 8 or negative 8. Let's try another. What if we know that the quantity w plus 3 squared equals 20? Well, again, this is an equation we're solving, and we start with the outermost thing and work our way in. The outermost thing going on the side with w is the square. So the first thing we're going to do is take the square root of both sides. Taking the square root of this side will leave us with just what's inside there. That's plus or minus the square root of that 20, right? But we still haven't finished solving for w. We've got to subtract that 3 over. So for 3, we've got plus or minus the square root. Oh, 20's got a perfect square inside too, right? So let's work on him too. 20, that's 4 times 5, minus that 3. So how does this guy simplify? Plus or minus 2 square root of 5 minus 3. So my two options for W are this with the positive, right? 2 square root of 5 minus 3. Or the other option is with the minus, negative 2 square root of 5 minus 3. All right, so we're still going to get two solutions, but it is possible that that square isn't the last thing we have to undo. So as long as we're careful, take it one step at a time, start on the outside and work our way in, we should be fine. All right, let's try a couple more of these. How about v plus 8 quantity squared minus 63 equals 0. Why don't you try this one? So take a minute, pause the video, see if you can work this out. What are the two options? What do you get for v? The first thing we have to do is add that 63 over, right? Because the outermost thing happening is subtracting it. Oops, quantity squared. Whoops. 63 this time. So add that over. Now the outermost thing is that square, so we take a square root of both sides. Anytime we take a square root in an equation, we've got to have the plus or minus. There are two options. Could be the positive version or the negative version, because either one, when I square it, gives me the number. And now I subtract the 8, right? The last thing here is this plus 8, so we'll subtract it from both sides. And let's see, should we work on this square too? There's a 9 in there, isn't there? 9 times 7 is 63. So we've got plus or minus 3 square root of 7 minus 8. So our two solutions for v, it might be the positive one minus the 8 or the negative one. And minus the 8, it always stays the same. It's minus 8 no matter what. All right, did you get that? If you tried it on your own? Let's do one more together. Then you can try it in Alex. How about w minus 3 quantity squared minus 54 equals 0. So just like the last one, start by adding that 54 over. Now the outermost thing is a square, so we'll take the square root. 54, that also has a 9 in it, right? 9 times 6. So that's, oops, we need that plus or minus on these guys. That's 3 square root of 6. And now we can add over the 3. So we've got plus or minus 3 square root of 6 plus 3. So our two options for W are the positive, this piece, or the negative. Whoops, 6 plus 3. All right, like I said, we've really already seen this when we were solving those triangles using the Pythagorean theorem. But they can happen in any equation, and when it's not a triangle that requires a positive length for the side, we do need that plus or minus. All right, let me know if you have any questions. Have a great day.